probably going to need to check it out this weekend. But I'm totally good with basically us just doing a few examples and then getting you guys going on homework. To that end, let me go ahead and get a book out and open and ready. How many of you guys have already started the integration section 4.5 homework? Okay. So for the most part, I can just start in the first few problems and then we can work with that, I think. And that's section 4.5, yeah? Okay. I want you guys to go ahead and start this problem. I'm going to go ahead and just scan the first few pages of homework and attach it to the homework assignment. That way you guys can just open your Google Classroom in just a moment and just start playing with homework together. And those of you guys that have already started, you can pick up wherever it is that you left off. But I want you guys right now, who do you think is your you? Okay, yeah, I know you don't like it because you're like, if you were tracking it all yesterday, you're like, that doesn't make sense. I don't think it's going to be very helpful. Yeah, just go with u equals x minus 1. I want you to do as much as you can following the examples from yesterday. I know it's not going to be quite as nice, quite as neat, quite as, what did we call it yesterday? Not going to fit quite as perfectly or exactly or nicely, but that's okay. That's okay. Yeah. Oh, do you need it desperately? Okay, go get it, go get it. Okay. Don't get lost or distracted. Okay. All right, here we go. Section 4.5. Where are we going? So you guys are trying to do as much of this as you can following the example from yesterday. Where's your stuff?
Oh, I just had anything. Like, I was rushing like 10 minutes ago, but I didn't realize it.
Okay, hold on. Okay. Okay, here we go. Now the answer keys, you should be able to figure out how to get the score out of it. Okay. Hold on, that's confusing. This is called an answer key, right? For the answers. Okay. These are given. So you're going to be grading them. If it's wrong, you're going to write the right answer. Okay. Each one is worth 2 points. So 1, 2, 3, 4, 5. The bonus is worth +2 if I did it. Check mark. +2. Okay. If they did the 18, they get 1 point. If they did the 7, they get the second. This one can be half point. Does that make sense? So try to give them a score out of 10. I'll double check. Double check and make sure. Each one's worth 2 points. You can give them credit if they lose. Do you need a blue pen? All right, talk about it in your groups really quickly. What have you been able to do and where are you stuck? Are you stuck? You should be stuck. Unless you're being very creative and very thinking, well, very creative and thinking outside of the box. It's okay. You're supposed to get stuck. Can you think of maybe how to proceed forward? If you're stuck, have you thought of what or how or why you're stuck? What or how or why you're stuck? And how to keep going. Something that we haven't done yet, and yet we're going to need to do. We're trying to substitute. Hopefully you've substituted as much as you possibly can. And yet there's still something left that shouldn't be there. Can you think of a legal way of getting rid of it? So I don't know what homework problems you have, so I'm taking pictures of all of them. Yeah, Catherine. Some kind of what? I like the creativity and what you're thinking, but I don't think a log would be helpful in this one. Logs are good in bringing down powers. But I think, well, I'm just curious. You guys try to verbalize what's weird, what's wrong, what's off, what's not working. The x squared is still there. Are you guys seeing it? The x squared is totally still there. And the problem is, can we take an integral? Okay, I think I got it. Can we take an integral in terms of u and x at the same time? No. We can't take an integral in terms of u and x all at the same time. So therefore, technology is not let me today. So du is equal to 1 dx. dx is equal to du over 1. That's not very helpful if you guys are realizing from yesterday that we're supposed to be coming and plugging in and getting rid of stuff. Because in this one, we get square root of u du, the x squared is stuck. Now, I think you might be thinking, Kathleen, some sort of log might, but the problem is the x will still remain. So here's the crazy thing, and here's why I call it, no one else probably does, but I call it integration on crack. Because it's crazy integration, it's out there integration. We can technically say the substitution is what's crazy. It's not so much the integration is, but it's the substitution. Because we did all the things that were enough for the examples yesterday, and it's not enough now. But if it's not enough, we can't proceed forward. You don't antiderive. There is no legal way to keep going with the antiderivative. So if we can't keep going this direction, we look back and say, what else can we know? We knew that u is x minus 1. We knew that du is equal to dx, which means dx is equal to 1 du. That's an awkward, kind of messy du. So here's the dealio. Remember how yesterday I said, let's solve for dx because dx is always there? And so that's how or why we were solving for that. And then u, it was like, hey, you got it from somewhere, plug and chug. And we weren't touching whatever else was there because it was always going away, or at least the variables were. This time it didn't, but here's the dealio. If I were you, I would find some different colored pen and say, okay, there's an x, and I have issues. This one I don't, because he's just going to be substituted for a u. He's fine. This x is in a dx, and I'm going to get him after I find the u prime. This x, okay, well, I get it. He's stuck, but question, where else in this entire setup is there an x? Wait a minute. There's an x here. There's an x there. Can't I rearrange this and say that means x is equal to u plus 1? The same way I could say u is equal to x minus 1 from underneath the square root. If I need to get rid of an x, if I need to do more substitution, well then go find where else x is. Not inside the dx, that's taking care of this. But over here in the u expression, I actually have an x that I could put in terms of u. We just haven't needed to yet. But now that I have an x in terms of u, I can actually, now some of you are like, that's not going to help. It is going to help because check it. I can go ahead and plug in u plus 1 times the square root of u, or if you like it better, u to the 1/2. And it's not going to help in the sense of me immediately anti-deriving, but it is going to help in the sense of me multiplying and then anti-deriving, because what's u to the 1 times u to the 1/2? U to the power of, oh, come on, u to the 1 times u to the 1/2? 3/2, makes sense. U to the 3/2 plus, and then 1 times anything is itself, u to the 1/2. What was impossible for me to integrate before, because I could not get under the square root, is now totally possible, because now nothing's under a radical. Everything is freed up to go ahead and distribute, and then combine like powers, or I should say combine like bases. And now this is something I can totally solve. Yeah. Where? Oh, bummer. I didn't see this one. No, that's totally illegal. Thanks, kid. which means I have a little more work to do, which is kind of annoying because I have to not just put in u plus 1, but u plus 1 to the power of 2. So we're still going to do that u to the 1/2, but the sad thing is I'm going to have to FOIL first. Good catch, kid. And then when I distribute, I have u to the 5/2, a little bit messier. When I distribute, now I have a 2u to the 3/2 after FOILing, and distribute plus u to the 1/2. Ooh, it's even messier than it was before, but still possible, whereas it wasn't before. The mistake that I made that you guys might not have caught if you were just kind of following along is that it was x squared, and so I needed to plug in x and still have that quantity squared on the outside. Kathleen caught it. Maybe some others of you saw it. She voiced it. So then, we go ahead and anti-derive and get u to the 7/2 times 2/7 plus 2u to the 5/2 times 2/5. I didn't leave room for that extra fraction. Here we go. U to the 5/2 times 2/5. If you need it, you can do that little over 1 to help you with the fraction multiplication. And then u to the 3/2 times 2/3. And the AP loves these ones because if you were to take the u expression and come down and bring them in, I think u is equal to x minus 1 or something like that. You'd be like, please, 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 let me box it and be done. It's awful. And the AP is like, you should factor because things get a lot nicer. Which is a little mean, and so to be honest, I'm going to not plug in the x minus 1 yet. Because if the AP is going to make us factor, which they totally are, because there's a much simpler way of writing this, it's probably easier to factor now than later. It's probably easier to factor now than later. Meaning, well, they like to be even messier. They're going to come through and see all these fractions and be like, ew, gross, which I mean, you guys do too. But they're saying ew, gross in the sense that they're saying get a common denominator and pull out all the fractions, which that's why you're going to say ew, gross. I'm trying to think of what 3 and 5 and 7 all go into. I'm assuming it's 85 because it's 15 times 7. I'm not sure if there's anything that's less than that where they would all go in. Those, of course, 35, but he doesn't go in. Those, of course, 70, but he doesn't go in. These 15, 30, no. I think 85, so we're going to have to multiply this one by 15 over 15. This one by 21 over 21. And this one by 35 over 35. Which is annoying. But the reason they're doing that is because then they can pull out an 85. A fraction of 85, or 85ths, I should say. They can also pull out a u to the 3/2. This is just factoring, no calculus involved, but there is a u to the 3/2 in all of these dudes. If I was to find, well, actually, right now, I can see a 2 that can come out of everything, so I might just pull out a 2 because I see it. And when I do that, when I pull out a 2 and an 85, I can ignore, I can ignore all the denominators. So I can ask myself what's left. This one I see 15 u to the 7/2 minus 3/2 is 4/2, which is squared. This one I have 42. 5/2 minus 3/2 is just u to the 2/2, which is 1. And this one is 35, and then all the u's are gone. And I know to some degree, like this is a mess. However, look at it. You had all these messy, like tons of u expressions and tons of fractions. Now all of that is out here, and I have a nice little, in a sense, quadratic left over. So what the AP would then do is go ahead and take that expression which you had, x minus 1. Then they would go ahead and plug that in. And to be honest, they're not usually quite this bad in that this one ended up, that squaring thing made it a little bit worse than most of theirs would be. If you guys see it, this is something where before I don't know how to raise to the 7/2, the 5/2, the 3/2. I'm stuck. I'm done. But now, I have something where, hey, I can actually square x minus 1, and I can multiply by 15, and I can add 42x, and I can subtract 42. And my smartboard, like every other piece of technology this morning, is not wanting to work. Patience is a virtue that I am not perfect at. We get x squared minus 2x plus 1 times 15, so 15x squared minus 30x plus 15. And all of this, guys, would be unnecessary if it was a long answer. From my experience, I just know this would be a multiple choice if it was anywhere. And you would need to be getting a nice, pretty, make it match answer. But what you wouldn't have been able to make match way up there, after you do this factoring, after you do this, hey, what's in common? Like the green pen trick, that's why I got my green pen out. What's in common? Pull it out. Then we can go ahead and simplify and see something like we have 15x squared minus 30 plus 42 would be 12x. Negative 42 plus 35 would be 5 and 2 is negative 7, and 15 minus 7 is 8. Something like that. Plus 12 minus 7 plus 8. Anybody backing me up? Seen a mistake? You can stop me now. I think it's good. And if they're really mean, there's some way of factoring that. So 8 15s would be 4 30s, which would be 120. 12 and 10, that's not going to help. 8 and 15, that's not going to help. 6 and 20. Oof, that's close. Maybe there's not anything. Anybody see any factors? 7 doesn't go in, right? No. And 8 goes in 15 times. And 6 goes in 20 times. 4 goes in 30 times. No. It's getting farther and farther apart. You guys can check it. But if that's truly as far as we can go, then we would be finally done. Which, even though you're like, it's not even that nice. Well, it is a whole lot nicer than it used to be up here with 2/7 and 4/5 and 2/3 with used all these different fractional awkward powers. Now it's at least like a quadratic times, okay, one little radical there. I'm going to save number 2 for all of us to kind of have fun with on Monday, just because, well, all the kids who are absent need to enjoy this too, right? Tongue-in-cheek enjoy. I know it's a little bit rough. But let me get this guy up here. Bloop, 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 bloop. Okay. Since we're skipping that one, I'm going to leave this up on the screen and freeze it. It's kind of like a, okay, U sub, what are the basics? U sub, what are the basics? But not even just U sub, actually taking into account all the things that we've been doing since section 4.1. Now that we've done U sub, it's kind of the grand culmination. So just a reminder of any integral antiderivative problem you have to do. Maybe there's a direct rule that you can just plug and chug from that big old table. Driver card number 28, 29. Maybe it's not a direct rule, but a quick little multiplication, no big deal. Let's not do U sub on that. Like, shoot, that's so fast. But maybe, oh, dear Lord, let's do some U sub, or let's do some U sub, or and some of these, actually all of these, you have to do U sub. A quick little boop wouldn't make it a basic rule. And at the very bottom, we have this creative math. So this is kind of a grand culmination in a sense of, hey, integration, antiderivatives. Now that you've learned U sub, I mean, we're going to talk about a few other trickier rules like inverse, trig, backwards, etc. But otherwise, we have formed the foundation once we've done U sub of how to tackle integrations. I'm going to have you guys write this down. I'm going to go ahead and throw in Google Classroom. Maybe it's not going to help you guys tons since there were a few different things that delayed our class. I apologize. But it will be on Google Classroom today, the PDF versions, if you guys are playing around with, or if you have like some study halls in classes today because people are gone. You can just pull up that Google Classroom and play with homework because the PDF will be waiting for you like a test review. Ooh, there's music next door. So the nice thing is I need you guys to realize before the weekend and before you start, like, I'm not going to even work on this homework because it's not due till Tuesday. Please realize not all the problems are as hard as the one you've just seen. Please realize not all the problems are as hard as the ones you've just seen. Or the one you just saw. Sorry, we only did one example. All right, I think it should be, let me double check that it's working. And, booyah. I'm going to come back to this page because some of you are still writing. But we do have section 4.5 just chilling in your Google Classroom underneath homework number 30, right? Awesome. We go back to the notes. Bloop, bloop. And I'm not going to solve every single one of these just because it'd be a good thing also to go over when everyone is here. But I will at least start a few of them. For instance, up here we could say integral of secant tangent. Once you have those trig rules memorized, it's just like, boop, boop, got it. Or this one, okay, fine. It's not immediately ready, but after one quick multiplication, it's like, aha, now I can apply the basic rule. Bloop, bloop, done. I get my C in it. But then these ones you have to think about, ooh, what is my u, 5x plus 7? What is my du, 5dx? What is my dx? Oh, du over 5. I'm not going to solve it, but then we have to plug in and go. This one, what is my u, 5x? What is my du, 5dx? What is my dx? Remember, this is what we were doing yesterday. These ones weren't horrible. It was all about the plugging in. This one would be a little bit messier because x plus 3 only has a du of 1 dx. And if you notice over here, du over 1 is just du. I'm going to have somebody extra. But it's the only way to proceed forward because where I could split up division in old school problems if these were flipped, since my binomial is in the denominator, I can't split up a denominator. I can only split up numerators. And then this whole creative math should probably be scaring you just a little bit because it's like, oh crud, sometimes this isn't enough, even the integration on top. I should say substitution on top because that's what's really crazy is the substitution. You can call it crazy substitution if you would prefer. Sometimes the math seems to be on drugs and you should not be. The creative math is just stuff that we're going to see and we're going to play with. Not necessarily something to memorize, just to be like, nothing's working. Can I maybe go look at those creative math tricks and see if one of those would help? But that's something probably going to need to see some more examples from me over the next few sections. All right, guys, it's up to you in the sense of, I think we have only a few minutes left. Let me check out our schedule as I write it on the board for everybody else today. We have until 32. We have like a minute. So if you guys want, you can go ahead and check out Google Classroom at any point today. If you guys have any spare time in your classes, you can play with that homework. If you need anything, come find me during period 7 or after school. I'll be here probably for an hour, hour and a half. I have a kiddo who's doing a makeup exam. Hopefully they are. If not, I'll probably take off a little bit sooner. So if you need me, come find me. And otherwise, happy minimum day. Happy Friday. Happy those of you that don't need to come tomorrow for the open house. Happy weekend. Yeah. Go get something fun for lunch today or something since you guys don't have to stay on campus. That's my advice. You guys good? Yes. All right. You guys can get out of here if you want. What do you have, like 15 seconds? Or you can sit and relax for a little bit and enjoy that we didn't have to do too much. Those of you guys that missed class today, please have your notes ready to go on Monday. And if I were you guys, I would try to get as far as possible in this homework because Monday night, if you haven't started it, oh, it's going to be sad. But if you have started it, hopefully on Monday,